Hi, this is Kurt Seifried with the Cloud Security Alliance, and today I'll be talking about data security with generative AIs and large language models. So first, a little housekeeping. Here is a QR code to the supporting materials for this talk. There should also be a link in the comments below. There'll be the Miro diagram and so on. And then here is a QR code link to the video itself. It just seemed like a good idea to put that in. So we're going to be talking about large language models and data security because a lot of organizations right now are hesitant to use these new AI services and providers because they have somewhat unknown concerns about data security. This is a very new topic, a very new area. Some of the providers have only been around for a few weeks. And so there's some understandable hesitancy and nervousness. So we're going to look at this, going to draw a bit of a diagram. And the good news is we've already done this once with cloud, right? We went through cloud being uncertain and maybe not necessarily trustworthy to now kind of being the default way we do IT. So we can definitely overcome these security risks and issues and build systems that are safe and trustworthy. So let's clarify the problem a bit. So the first off is we have an AI provider, and they'll have a front end, and they'll have a large language model on the back end. And obviously, this is grossly simplified for the purposes of this talk. I don't want to get into the weeds. And then the way a user interacts with it typically is, they'll generate a prompt. The data and the prompt will be sent in. So for example, a question and maybe a PDF that you're asking the question about. It goes into the front end. The front end tokenizes it, whatever, sends it to the LLM. The LLM processes it, sends back a response, and the front end replies to the user. And the user is hopefully happy with their response and goes on about their day. And then obviously a lot of these models have shared tenancy. They're used by more than one user. AI models tend to be on the expensive side as far as compute and running them goes. So let's add a second user, as sort of the common case. So second user sends in data, goes to the front end, goes to the large language model. And now I made this icon gray to sort of represent the mixing of different colors. Unfortunately, Miro wouldn't let me do a rainbow or multiple colors in a box. So we'll just assume gray means the potential for mixed data. So that data goes back to the front end, and that front end goes back to the user. So the first comment is within the LLM, the data is stored at least temporarily because there's the context window. The LLM needs to know what it's talking about, so it obviously has to store that data in memory somewhere. But typically, these large language models don't store that data permanently or forever, right? The query comes in, they process the query, they send the data out, and then they flush memory and prepare for the next response. And so we'll sort of assume that's the general case, that the large language model itself is not storing data. However, a lot of these AI providers want to collect training data. And so their terms of service explicitly says, we're going to record all the data that you send in and keep it around for training purposes to train new large language models. So in this case, the front end basically dumps the data up into some sort of storage. And that is then used at some point later on to train a new large language model. You get a new large language model, and that is, used in future. So with this type of system, then there is obviously the potential for security problems because your data is being stored. We've already seen this happen. OpenAI, for example, was temporarily banned in Italy, and then they essentially added support to turn off your history and turn off the recording of your data and the usage thereof for future training. And then it was unbanned in Italy, and life goes on. So you can, with some providers, you can just simply turn this off. So we've now clearly established there's at least one very valid concern. So secondly, if you're storing people's data, there might be a security flaw, right? So let's add an attacker to the diagram. Now, The thing is, if the attacker is attacking the back end systems, so they're basically trying to, for the sake of argument, they're port scanning or network scanning the provider's IP ranges. They find an unsecured S3 bucket or some other data storage system, then they're going to attack that. But to put it bluntly, that's not an AI problem. That's a very classical cloud security problem, right? Most of this infrastructure is going to be running in the cloud, or if not on premises or whatever. But fundamentally, it's not an AI problem. It's classic cloud or enterprise security problems, access management, data security. So the good news there is we have guidance on this. We have decades of experience of securing these. So I'm just going to remove this because this is not an AI specific problem. In so much that, it's the same type of problem you have with Gmail or Microsoft Outlook, where, obviously they have a backend data store. And if they were to somehow expose that to attackers, they could read your email. Now, that's not an email specific problem. It's simply a data storage problem. So the next thing we have is validation data. So you might be in a regulated industry, or you might simply be in a jurisdiction that requires it, but you might have validation data to ensure that your prompts and the output are safe and secure and legal even. So basically the users would, submit some validation data that the provider would use when, when answering a query. Now, the thing to note here is, I made the validation data block gray because it is technically multi-tenant, but the data it's very unlikely to be commingled for the simple fact that if you have tenant A, and let's say tenant A is building an AI to be used by children, well, they're obviously going to have a lot of validation data around making that safe. And that will essentially cripple and break the AI for anybody else who has, a more regular use case, maybe dealing with adults. So I've made this gray, but I think realistically, validation data is not something that will be commingled because, quite simply put, it will be too restrictive and break things for the other tenants. So I don't think we have to worry too much about that, but we'll leave it in the diagram for now. So now we've established that there are sort of two legitimate concerns for data leakage. So there's the people who say there's nothing to worry about. There is something to worry about. So finally, and I'm going to grossly simplify this. What happens when you take this stored data and train a new large language model? Well, basically, you're taking all this textual data and you're mining it for meaning. So for example, and then you come out with what's called a vector database, which is again, grossly simplified. It's pairs of tokens, and we're just going to pretend that tokens are words. Tokens can also be parts of words, but let's pretend that they're just words, and then they have a weighting that connects them. So for example, apple and store and a weighting of 0.2, or apple and tree and a weighting of 0.4, because maybe the phrase apple tree is much more common in your data set than the term apple store. So the first thing is that if you put in sensitive data, like say a social security number or a person's name, it's not necessarily going to end up in the LLM weighting and data unless it's quite common, right? Like a single instance of something is unlikely to end up in the data. And so a phrase would have to be pretty common, for it to end up in the data. So let's actually do a quick demo. So here we've got a window open with ChatGPT-4, and we'll type in quick and see what it says. Okay. Please complete the phrase quick. Oh, interesting. I was actually expecting a quick brown fox, or interesting. So I was actually expecting the quick brown fox jumps over the lazy dog, which is what I previously got when I was testing this out. which also sort of proves my point that even if I sort of am looking for something specific, it might not pop out. So let's actually just kind of the quick brown. Hey, there we go. Okay, so that finally worked. And let's try one more. Please complete the phrase. A bird. Wow. Yeah, see, and what I was actually looking for was a bird in the hand is worth two in the bush, I believe is the expression. So this is the perfect example of the attacker, even if there is a specific phrase in the large language model that has a heavy enough weighting to pop out, it's not necessarily automatically going to pop out in the, yeah, see, there we go. At that point, I basically would have to know half your trade secret or more to get it out. And so, well, let's try something like that. So let's describe, say, a novel chemical process to isolate nitrogen from the air. And herein lies the second problem for attackers trying to get data out of large language models is this whole thing, and it may or may not be correct. So this appears to actually be hallucinated. So let's tell it that. That was hallucinated. Please describe a real process you found in the literature. And there we go. So now it actually proposes some real world nitrogen fixation strategies from air. And the difference being, though, is this data is not really coming from the large language model itself, but from sort of a library of data. So to put it simply, if the generative AI provider is storing incoming data and then making it available verbatim as sort of a resource library for the generative AI to mine, as it answers questions like looking up currency values or, what's the capital of country X, then obviously, yes, that's going to potentially result in your data leaking. However, I haven't run across a single AI provider that stores data and uses it for anything other than large language model training, right? So far, I haven't found one that stores the data and then uses it to feed the GAI LLM. So I really, while that is a potential path for data exposure, it seems unlikely because it's something that is so risky and so obviously problematic, like storing your data and then straight up exposing it to other tenants if they ask a question related to that data. Again, that's a cloud security problem. That's not an AI specific problem. That's the same as, well, if you have some sort of document management system and you're exposing documents to other tenants, right? That is not an AI problem. That's a cloud problem. That's a software problem. So again, we have something that sort of looks like an AI problem, but fundamentally is just an old problem in new AI clothing. So the good news here is what this means is, from a security perspective, the vast majority of this can be solved by using, mature security practices, strong controls, the typical multi-tenant protections. So when you're looking for an AI provider, look for one that has their SOC 2 report, look for one that has their CAIC, their Common Assessment Initiative questionnaire or STARS document and information released publicly. So for example, OpenAI is a really great example of this. They have a huge pile of, their security certifications, and they even indeed have a CAIC Lite document for their OpenAI, ChatGPT. The second thing, obviously, is check the terms of service. So for example, the CSA is currently testing out a vendor for our support answer bot. And specifically, the vendor talks about, and I quote, fully self-contained bots with no data sharing between bots, even within the same account. So the idea is you have a bot trained on some data, and it's specific even within your account to that project. Like the bots don't share data between projects. And they also say, we never store your files unless you choose to see them in responses. By default, your chatbot is private, which means only authorized users can query your chatbot, right? So again, by default, they make a chatbot that is private by default. And unless you do the work to expose it publicly on your website or whatever, attackers can't talk to it directly. So it's one of the reasons we're looking at them, because they take data security seriously. Another option is to look for generative AI large language models that are done with these tenant-specific deployments. So a good example, Microsoft Copilot, the demo videos, they show Copilot going through your data to answer your questions. And that's it. It does not go through other people's data. It doesn't go through, it doesn't share your data with other people, unless you configure it. And I'm not even sure that that's a capability that they provide yet. So another option is if you have a really high security need. So for example, there's government departments that have data that is kept on air-gapped systems, and no doubt they want to start using AI to process that data. Satellite imagery, for example, you can now use AI image recognition to count military vehicles. And so, wouldn't it be nice to, in addition to having all this satellite imagery, maybe have like a real-time count and spreadsheet of every military vehicle on the planet? I see no reason why this isn't possible with enough compute power. So the answer there is you can just run your own generative AI on premises, even air-gapped if you need to. It's certainly not super easy, but it's also possible. I mean, even on this Windows 11 workstation I'm using to do this presentation, I have been experimentally running large language models, including the Llama 2 with the 7 billion parameters. It requires about 14 gigabytes of VRAM, and I just managed to squeak it in. I currently have a 4 gig and a 12 gig video card, so a total of 16 gigs of video RAM, and it just managed to fit in. And it was providing me with not the most useful responses, because I need to give it a bit more context and training, but it worked. And so obviously, a large government agency with air-gapped systems is going to have a bit more funding and money to build those systems. And fundamentally, if you look at these problems and these solutions, it's starting to look a lot like cloud, right? The parallels are pretty much identical. And even the problems that look AI specific, like, oh, we're going to take your AI data and use it to train a new large language model. Well, that's really just a data commingling and storage problem. And either find a provider that doesn't do that, or, tell them not to, or run it yourself. There's a lot of solutions that are essentially identical to the cloud data storage solutions. If you don't trust somebody like Amazon S3 to safely store your data, well, then you have other options, both in the cloud and outside the cloud. So in summary, can you safely use generative AI, large language models that don't result in data leakage? And the answer is most definitely yes. Can you use cloud-based AI, generative AI, large language models in ways that don't result in data leakage? Again, also yes. And do you need to worry about the providers that will store your data for further training of large language models that other people can use, resulting in a leak of the data? This is definitely a potential possibility, but I believe it is highly unlikely to be exploitable, because there are just so many hurdles. First of all, there would have to be enough instances of that data for it to kind of nudge the training model into having that specific string of text. Secondly, the attacker would very much have to know what to look for, right? You can't just ask a large language model prompt it, be like, give me all your trade secrets that are embedded in your training, in your large language model data. Is there a legitimate worry if the large language model provider stores your data and then provides it verbatim, as source data for other people's queries? Well, obviously, yes. But again, that would be like, an email provider saying, when people search email, we'll also allow them to search your email to get better results. Like, nobody's going to do that. That's so insanely dangerous and obviously bad that that if you do find a provider doing that, well, you shouldn't be using them. And so another question that comes up is, well, how do I trust these generative AI LLM providers to be doing what they're saying and to be secure? And the answer is the same way we did with cloud. They'll get certifications, they'll get maturity and trusted. And I mean, we're already there for several of them. Microsoft, for example, Amazon, Google, the big three cloud providers are also three of the seven big AI providers. If you go by the White House, the White House invited 7 large AI providers this week to agree to some voluntary AI safety standards. And so, to put it bluntly, pretty much all of us already trust Amazon, Microsoft, and or Google to some degree. Well, use them as your AI provider if you don't trust the smaller players. And so, in summary, the AI problem is mostly a cloud problem. And that's good news because we have things like the Cloud Security Alliance. We have a lot of knowledge. We have a lot of practice. We have best practices. We'll have to tweak them a little bit for some of the odder parts of AI, like the prompt injection. But fundamentally, this is something we can solve and something we can do. So thank you for your time, and I hope you have a great rest of your day.